Hi, so today we're going to talk about solving linear inequalities, and we're going to not only solve the inequalities, we're going to graph them and also write their solutions in interval notation. So, a couple rules we have to remember about solving linear inequalities. Got a little helper today. Yeah. We solve them just like equations. I have an added rule that I always bring the variable to the left when I'm solving inequalities. Okay. But the other thing we have to remember is that anytime you multiply or divide by a negative in a coefficient, that the inequality symbol switches. Okay, so the first couple questions we have here actually don't require any algebra to solve. They're already solved. So x is less than 3. So don't get too creative here, guys. Throw a 3 in the middle of your number line. So you're a 2, you could be a 4. I'm sure you can count. And the thing we have to remember is that a long time ago when you learned these, you guys used open and closed circles. So when it was a less than or a greater than symbol without the equal sign underneath it, you would use an open circle and you would use a closed circle on the other ones. Well, in Algebra 2, since we're going to do interval notation, you have to use the open parentheses or the closed off brackets as opposed to the circles. So everything less than 3 would be us shading everything less than 3. Oh boy. And then at 3 itself, because it's not included as a solution, we're going to be putting a curved parenthesis. And the reason we want to write it that way on the number line is because when I ask you for the interval notation answer, we always read intervals from left to right or least to greatest. So if I think about the leftmost thing that's shaded, what lives way down here on the number line, that would be negative infinity. So my interval begins at negative infinity and then colors in everything until I hit 3. And then because I already have a parenthesis on 3, I'm going to put a parenthesis on the interval. And then the infinity is kind of a weird concept because you can't actually get to infinity. So you never would put a bracket on infinity. It's not a location concept. So a parenthesis goes on any sort of infinity, positive or negative as well. So same thing here, it's already solved. We're going to throw negative 2 in the middle of the number line. And then on the left of it would be negative 3, and then right of it is negative 1. Going with that. And we're going to put a bracket this time, but I do need to graph greater than negative 2, so we're going to be shading to the right with a closed off bracket. And then your interval always begins at the left portion of your coloring, so it starts off at negative 2 with a bracket. And then it colors everything to the right, which if we think about what lives way down there on the number line, it would be positive infinity. And we just talked about the infinity concept. You can't actually get there, so you always put a parenthesis on the end of an infinity interval. So that's a little reminder about interval notation. Hopefully your Algebra 1 teacher gave you a little insight into that when you did Algebra 1. So here we do have to solve. So just remember the rule about if you multiply or divide by a negative in a coefficient, you have to remember to switch the inequality symbol. And then my rule is I always keep the variables on the left when I'm solving. That way I don't have to worry about kind of flipping things around. I suffer from pretty significant dyslexia, and I'm really tired right now, so it's going to be really bad if I start trying to flip my interval or my inequalities around. So we're going to solve this by adding 8 to both sides, just like I would in an equation. 5y is less than 20. And then we're going to divide by 5. Now 5, the coefficient is not negative, positive, so we don't need to worry about flipping any signs, so it's still a less than symbol. But now my solutions are everything less than 4. So 4 in the middle of the number line, everything less than him would be yonder. And then because it does not have an equal to bracket, we do not include 4 as a solution. So writing my interval notation answer, I start over here on the left, which is, think about who lives way down here, is negative infinity. So negative infinity, that was Logan, to 4. I'm going to yell at my kids for a minute, and we're back. So the next question is still needs a little algebra we got to solve. So we're going to subtract 5. Please watch that negative coefficient on x. It is not gone. It is still there. So greater than or equal to 22. Now here, when I'm solving it, I do have to divide by the negative 2. So that rule that I have to remember is going to take effect. The solution is x is less than or equal to negative 11. So negative 11 in the middle of the number line. To the left it would be negative 12 and negative 10. Everything, remember we flipped it now, it's less than negative 11, so going this way. And then because it does have an equal to bar, we've got to put a bracket. So intervals are always from left to right. So down here, the interval starts at negative infinity, then continues until negative 11 with a bracket. And then this last one, we're going to add 7. And remember a quick way to get rid of a coefficient that's a fraction is to multiply by the reciprocal. So multiplying by 2/3 here. Nance wants to show you all her cursive handwriting that she's practicing. Yeah, lovely, huh? It's a lost art. Alright, so here x is greater than, let's see, 6. So, setting up my number line. Everything greater than 6 would be this away. And then does not have a bracket. So we have a parenthesis on. So my interval begins at left part of it, so 6, and goes to infinity.
Are you done?
No, I'm not done. We have more to learn. Alright, so remember my rule. Variables always to the left, even if that makes things negative. We'll get over it. We'll deal with it later. So I'm going to subtract the 6x over here. At the same time, I'm going to go ahead and subtract this one. Because if the variables come to the left, then the constants have to come to the right. So we have negative 4x is less than negative 2. And dividing by negative 4, remember that rule comes into play right here. Ends up being x is got to flip the sign. Now it's greater than 1/2. Negative 2, negative 4, positive 1/2. So, sure, y'all can count. The number line itself, I don't really care if you label it, frankly. I just need that center point labeled. I think greater than 1/2 would be this way. And then not equal to, so I have to use a parenthesis. So my interval begins at 1/2, then continues to infinity. Alright. We are learning about infinity. Yep. So we have some algebra. Alright, so remember my rule, x is always to the left. And so here we have a negative coefficient. That is going to be a problem in a second, that's okay. When we divide by the negative 1, same rule comes into play here, now flipping to a less than or equal to, now a negative 7. So everything now less than negative 7 will be this way. And then it does have the equal to bar, so we have a bracket on it. So remember your interval has to go from the left side to the right side. So our interval starts at negative infinity and goes until negative 7 with a bracket. What that means is the negative 7 is a part of the solution. If it doesn't have a bracket around it, that means negative 7 would not be included. But everything up until that point would be included. So negative 8.9999, something really, really close to negative 7 would still work. Alright, so here, subtracting 7n, also subtracting 6. Now watch this negative here, negative n, and then subtracted 7 gives us negative 8n. Is less than or equal to negative 2. Same rule. I have a negative coefficient again. Be alright. So now that sign flips. Does become a positive 1/4 though. So now we're stating everything greater than 1/4 or equal to, which means we're going to include 1/4 as a solution. So my interval begins at 1/4 and goes forever. Oh, not done. We have to talk about compound inequalities. Compound inequalities are where we're just going to have two inequalities put into one problem, and then they're going to have a conjunction between them, either the word and or the word or. And if you think about what and versus or, they have very different connotations. So if I were to say to my little baby girl here that, she has to go clean her room and she has to cook dinner, that's a lot of She says she can, but it's a lot of work for her to do. But I know you can. But if I change it up and I say, Natalie, you can either go clean your room or you can cook dinner. That gives her a little less work. Now, she could be a super girl and do both. There's nothing preventing that, but she doesn't have to do both. So an and problem is going to be a very restrictive statement, and it's going to have to satisfy both claims. An or is less restrictive. You're going to graph claims, and then if they happen to overlap, that's okay. But usually don't. So what's kind of weird about this section is this is like a cursor. When I took a screenshot of it, that wasn't there, so just ignore that. We call these sandwich problems because after a little bit of algebra, the variable is like sandwiched in between two inequality symbols. So you'll have like a number is less than x is less than a number, and that's another way of saying an and problem. So a really easy way to remember that is if you see it's a sandwich problem, you have to remember it's an and because it's got and in the word sandwich. So a little confusing the way they read it, especially for people like me who have a bit of dyslexia, because this part I can read fine. It says x is less than 1. So x is less than 1. But remember, there's an implied and in this question. The other part of this question is over here, and it says -2 is less than or equal to x. Well, that's really, really backwards. -2 is less than or equal to x. If I kind of flip the whole thing around, it becomes x is greater than or equal to -2. So it's written backwards. It's very tricky on a mind, especially a mind like mine. So when I go to graph this, I have to remember that I'm graphing things that are both greater than or equal to -2 and less than 1. So I am graphing things that are greater than -2 and less than 1. Those would be the numbers in between -2 and 1, wouldn't they? So the trick here, though, is because -2 had an inequality with a bracket, or the line underneath, we have to put a bracket. And then the other part of the inequality does not have that. So this ended up being kind of weird because it has one bracket and one parenthesis, but and problems will generally look like number and then some shading and then another number on the other side. It could be a bracket, it could be parentheses, it could be one of each. But that's what and problems will generally end up looking like. Now an or, we talked about the word or being less restrictive. Just ask that you have the possibility of both things happening. Does it mean they both have to happen at the same time? So we're just going to basically graph them separately. X is less than -1. See everything here. Or anything that is greater than or equal to 2. That would be everything up here. Now notice they don't overlap. Those two claims cannot happen at the same time, but that's okay because the word or was in the middle of them, so it said either this can happen or that can happen. So that's okay. So when you graph an or, basically what it's going to look like is you're going to have a number, you're going to have another number, and then you're going to be shading out to the side. So one year I was teaching this and I had a class that was really into like cutesy things as far as like remembering. And they said, oh, it kind of looks like oars on a boat. Like if you stick the oars outside of the rowboat and then you like use them as paddles. I said, okay. So whatever makes you happy, guys. So when we look at number 8, I can tell by the notation of the way it's set up that it's a variable in the middle and then numbers off to the side of it. So it's a sandwich problem, which means these are all going to be and problems. What are kind of cool about when they set them up as sandwich problems is you can simultaneously solve both sides of the inequality at the same time. So your goal is to get this t by itself. So your first step would be to add 8, but what's neat is you could do it at the same time. You can add 8 to both the right side of the inequality, but also to the left. So we end up with one more line of work still. We have 4. No, we have 6 is less than or equal to 3t, which is less than or equal to 18. So one more line, we still have to divide everything by 3. So again, simultaneously, divide everything by 3. We end up with, I need more room. 2 is less than or equal to t is less than or equal to 6. On your number line here, I need to write down 2, 3, 4, 5, 6. And then remember, sandwich would be everything that's greater than or equal to 2 and less than 6. We're talking about the numbers that are in between 2 and 6. And these both have inequalities with lines underneath, we have brackets. So we're going to write the interval same way from left to right. So 2 to 6. And they're really easy to write the interval for because we like literally pluck them up like right off the graph and go like. All right, so the next sandwich problem still an and. We're going to simultaneously solve all the sides. We're going to add 3 to everybody. We have -9 less than or equal to 3x is less than, careful, we've got a different symbol here, 18. So then when we divide by 3, we end up with, need more room, -3 is less than or equal to x is less than 6. All right, go sit down with your weird hat. Thank you. Now, it turns out we're going to run out of room here as far as like tick marks go. So as long as you know that -3 is on the left side of the number line, and 6 would be over here somewhere on the right side of the number line, I'm good with that. So bracket on -3, but notice the 6 did not have a bracket. Parentheses. So the interval starts at -3, inclusive, and then all the way to 6. Next one's super easy to solve, just a one-stepper. We're going to subtract 4 from everybody. And we're going to have the same issue with, not enough numbers on the number line. So -13 less than p less than 6. So as long as you know -13 is smaller and further to the left on the number line, you're good. Parentheses on both of them this time. And there we go. So that's what sandwich and ands are going to look like. Ors, the graphs are going to look totally different. The work is actually a little more difficult simply because you have to solve 2 separate problems. So, you don't get it? Well, it's because you're still in 2nd grade, babe. Or 2nd. No. All right, so x is less than 1 if we solve that one. So we're going to have to go ahead and solve this one as well. Yeah, sassiness like a 10-year-old. Divide by 4 on both sides. So, you got to watch where your numbers go on the number line. 1 is smaller than 4, so you need to make sure that 1 shows up first. 1, 2, 3, 4. And then this time, we want to graph all the numbers that are less than 1, that'd be y'all, with a parenthesis, or all my numbers that are greater than 4. That would be all of y'all, with a parenthesis. So my interval, this is going to get kind of weird, has to go from left to right. So it starts way down here at -infinity, and then it keeps graphing until 1. And then this is where it's very strange. It jumps over a whole bunch of numbers in between 1 and 4. So every single weird decimal that shows up in between there is skipped. So the way we show that there's a jump is we put what's called a union symbol. So a union symbol looks like this. It's a U, and it does not have a tail. It's not cursive. It's just a really weird U. So it's a symbol. So it picks up again at 4, and then continues on graphing until infinity. So ors are, I don't know, they're not really that much more difficult, but the intervals end up looking kind of goofy because you have a union jump in the middle of them. So this one, there's stars next to the problem. That's not a good sign, right? That usually means something weird happens here. Let's check it out. All right, so we're going to solve this one. So -7. We have -2x less than or equal to -4, and then dividing both sides by -2. We did divide by negatives. We're going to have to flip the sign to a greater than or equal to +2. Come back to that one in a second. Or, well, that's the other thing I forgot to say about that other solution. When it asks you for an inequality solution, if you write x greater than 2 and then just this other part and you don't have the conjunction or in your solution, that's actually not correct. So we got to make sure this word or is there as well. Oh, gotta yell at my kids again. Hold on. We're back. All right, so we're gonna solve this one. -5 or subtract 5. Nothing weird happening here. We're not going to have to flip anything. All right. So, 2 and 5, if you think about the order of the number line, 2 would come first. 2, 3, 4, 5. So for the red part, I'm graphing everything greater than or equal to 2. So that'd be like this, right? Can you already tell this is going to be weird? And then everything less than 5. So what's happening is we actually are ending up, we're shading the entire number line. Which means, like, instead of having oars on a boat that were like this, our oars on a boat kind of like overlapped and end up shading over each other. So when I go to write my interval notation answer, my solutions begin at negative infinity and they end up going all the way to infinity. So this is what we call a special case. It does not show up often, but I like to, show you these because they do happen. We do have to watch for them, and standardized testing sometimes gives you weird, like, throw out some special cases there just to see if you're on your game. So, good to know. That concludes our lesson on solving linear inequalities, including compounds. Now, our next lesson is going to kind of play off of the concepts of ands and ors when we go to solve absolute value inequalities. Look forward to that.